Hello, my dear students. My name is Lakshmi Narayana. This is LN brand of chemistry. From the today onwards, that means the March 14th onwards up to the April 30, we are going to teach JEE mains second session for examination chemistry, previous year questions, and as well as EAP set in the Telangana and as well as AP. So both we are teaching. So observe it carefully. In case anybody they are not subscribed my channel, then subscribe it. So every day from the 14th onwards, the morning 6 to 7, the topics which are present in the EAPCET or JEE mains, then whatever we are discussed, then every day morning session all the concepts will discuss. Then evening session it is 7 to 8 every day. That will be problems from the particular topic. So మార్నింగ్ ఏ టాపిక్ అయితే డిస్కస్ చేసామో సార్ ఆఫ్టర్నూన్ ఆ టాపిక్ మీదనే ప్రాబ్లమ్స్ ఉంటాయి, న్యూమెరికల్ ప్రాబ్లమ్స్. సో టుడే మార్నింగ్ వీఆర్ డిస్కస్డ్ దట్ ఈస్ అటామిక్ స్ట్రక్చర్ చాప్టర్. So now we are going to discuss based on the atomic structure the previous year questions. JEE mains or EAP set, nothing but EAPCET from either Telangana or Andhra. So that all the questions we are discussed. Actually, this is one of the previous year JEE question. So look at once. So what is the question? If work function of metal is 6.63 into 10 to the power of minus 19 joules, the maximum wavelength of the photon required to remove a photoelectron from the metal is. So what we have to find out, wavelength of photon required to remove photoelectron from the metal is. Sir, here already we are discussing about what is the photoelectric effect. So then what is the formula for the work function? So work function, sir, psi that is equals to hc by lambda, right? So work function is given. So work function is given, that is equals to 6.63 into 10 to the power of minus 19 joules. So that we are taking here, that is 6.63 into 10 to the power of minus 19. It is equals to h value, then 6.63 into 10 to the power of minus 34 into c value 3 into 10 to the power of 8. So 3 c nothing but velocity of light, sir, h nothing but Planck's constant, then divided by lambda. So we have to calculate the wavelength. So wavelength they are asking, wavelength find out cheyali. So wavelength when it is in this side, so wavelength that is equals to the 6.63 into 10 to the power of minus 34 into 3 into 10 to the power of 8 divided by 6.63 into 10 to the power of minus 19, right? So 6.63, then 6.63 cancel both. Then 10 to the power of minus 34 is there. Then 10 to the power of minus 19 when it is sent up. Then 19 it will go positive. Then 19 plus 8 27. Then 3 into 27 minus 34, 3 into 10 to the power of minus 7 meters you can get. Once when it is shifted the point from here to there, then 300, then into 10 to the power of minus 9 meters. So 10 to the power of 9 meters nothing but is a nanometer, right? So we can say that is 300 nanometers. 300 nanometers. So answer is 300 nanometers. Okay, so noted this question. Then the remaining questions we'll discuss. Look at the next question. EMR of wavelength 663 nanometers is just sufficient to ionize the atom metal A. So atom వచ్చేసి metal, so metal A ని ionize చేయడానికి the wavelength 663 nanometers just sufficient. The ionization energy of that metal A in kilojoules per mole, you have to remember per mole. So generally, so when wavelength is given, so to calculate the energy equals to E equals to hc by lambda, we know that. Already h value మనం ఇందాకే చూసాం. So 6.63 into 10 to the power of minus 34 joule seconds. Then C is equals to what? C equals to, then 3 into 10 to the power of 8 meter per second. Then what we have to find out? Energy how to find out? So energy E equals to, then H value 6.63 into 10 to the power of minus 34 into, then next 3 into 10 to the power of 8, 3 into 10 to the power of 8 divided by, so lambda what will be there? So 663 into nanometers, nothing but 10 to the power of minus 9 meters, right? So then in case the point is when it is shifted to there, so that means 6.63. In case if you take 6.63, the point when it is shifted to here, 6.63, then 10 to the power of minus 7, then 6.63, then 6.63 cancel, right? Then energy, it is equals to 3 into, then 10 to the power of 8, when it is go up 10 to the power of minus 7, 10 plus 7, so plus 7, then 8, then 15 when it is removed from it, then 10 to the power of minus 19 you can get, 10 to the power of minus 19 you can get. The next, this is per joules per atom only, the energy of joules per atom. So but we have to find out per mole, kilojoules per mole. So per mole you have to take, means you have to multiply with the Avogadro number. So energy per mole, in case if you want to take 3 into 10 to the power of minus 19 into 6.023 into 10 to the power of 23. If you take, then you can get it is 3 into 10 to the power of 7, 4, 10 to the power 23 minus 19, 4, then joules per mole. Now in case if you want to find out the, if you want to shift it to the kilojoules, then here we can write that is, then here 3 into 6, then 18, so 18, nearly 18.06 into 10 to the power of the 4 joules per mole you can get. Then that is, so 180.6 joules, the kilojoules per mole you can get. So that is, so next question we'll discuss, note it all of you. Look at the next question. The de Broglie's wavelength of an electron in the 4th orbit is, they're asking question. It is one of the previous year JEE mains question. So January 2024 లో వచ్చిన question. So యాక్చువల్గా రేడియస్ ఆఫ్ nth orbit ఫైండ్ అవుట్ చేయడానికి, సో రేడియస్ ఆఫ్ nth orbit is equals to a0 into n square divided by z. This is the formula, right? So here a0, it is Bohr's orbit. Clear all of you? Right. Sir, here they're asking de Broglie's wavelength of electron in the 4th orbit. Actually, de Broglie's wavelength find out cheyadaniki from 2 pi r, it is equals to n lambda. You can take 2 pi r equals to n lambda. This is the formula. So in the place of r, radius of nth orbit, you have to substitute this. Then 2 pi r, in the place of r, what I told, this we have to substitute. What is that? a0 into n square divided by z, it is equals to, remaining what will be there? N into lambda. So n nothing but what here? So n orbit number. So what is there? 4. So 4, they are given 4. So in the place of n, you have to substitute 4. 2 pi, a0, then into, in the place of n square, 4 square have to take. So z value, this is this Bohr's atom. So that is hydrogen atom. So you have to take it as 1. That is equals to 4 into lambda, right? So now 4, then 4 cancel, then 4 to 8 pi a0, it is equals to lambda. So here what they're asking, so pi a0 dash pi a0, then 8 pi a0 is answer. So 8 is answer for this. Thank you. So note it. Next question we'll discuss. So look at the next question. Even this is also, so JEE means previous year question only. So based on the hydrogen spectrum, they're asking a question like this. So look at, observe the question carefully. The shortest wavelength of hydrogen atom in the Lyman series is lambda 1, shortest wavelength. Then the longest wavelength in the Balmer series of helium plus ion is, then options are given. Sir, option A 5 lambda 1 divided by 9, 36 lambda 1 divided by 5, then 9 lambda 1 divided by 5, then 27 lambda 1 divided by 5. Like this is given. Observe it carefully. So first hydrogen atom is given. So hydrogen atom, then shortest wavelength, they are mentioned the shortest wavelength. షార్టెస్ట్ వేవ్లెంత్ అని ఇచ్చినప్పుడు లైమన్ సిరీస్ అంటే మనకు తెలుసు. లైమన్ సిరీస్ n1 వాల్యూ 1 ఉంటుంది, n2 వాల్యూ, sir, when shortest wavelength is given, n2 value you have to take it as infinity. Then the formula to calculate the wavelength, we know that 1 by lambda equals to, right, Rydberg constant R into 1 by n1 square minus 1 by n2 square into Z. So Z, why you are taking here? So this is atomic number of that particular atom or ion. So here first, in the first statement, hydrogen atom only. So Z need not to take. So because Z value 1. Clear? Right. So now 1 by lambda, it is equals to R. Then n1 value 1 divided by 1 square 1. Then minus 1 divided by lambda. So 1 divided by n2 value infinity, right? So n2 value how much is given? Infinity. So 1 by infinity is 0. Then you can get from this 1 by lambda equals to R. 1 by lambda equals to R. Then, sir, here the wavelength they're asking. So wavelength lambda, they are mentioned, that is lambda naught. So in the place of lambda we are taking lambda 1, that is equals to 1 by R. 1 by R. This is for the hydrogen atom. Then in case helium atom, they are asking helium plus ion. For helium plus ion, longest wavelength is given. When the longest they are mentioned, remember, longest they are mentioned, n1 value it is equals to, so here Balmer series n1 value 2, Lyman after Balmer. Then n2 value 3. So because it is the longest wavelength. So next excited state only that you have to take. So n1 value 2, n2 value 3. So now wavelength you have to find out. So 1 by lambda it is equals to, then R into, then Z into, then 1 by n1 square minus, then 1 by n2 square. Then substitute all the values here. Then 1 by lambda it is equals to, then R into, right? So Z value how much for this? So Z value for the helium is 2. Then look at now. Then 1 by n1 square value. n1 square or 2 square, that means 4. Then 1 by 3 square, 9. Then next you can get it is 1 by lambda, it is equals to R into, then 2, then 5 divided by 36. Right? So 5 divided by 36 you can get. So not Z, Z square it is, I think. Z square, sorry. Z square. So that is 4, 2 square 4. So then 4 1s are 4, 9. So then 1 by lambda, how much you can get here? 1 by lambda it is equals to, then R into, then R into 5 by 9. 5 by 9. Then lambda is required. In the place of lambda, what you have to take? So in the place of R, what you have to take? So R equals to 1 by lambda naught. Then, so look at from here, R equals to 1 by lambda it is equals to, so in the place of r what you have to substitute, 1 by lambda 1 into 5 by 9, right? 5 by 9. So lambda is required means lambda it is equals to, lambda it is equals to reverse. So 9 lambda 1 divided by 5. So this is the answer for this, 9 lambda 1 divided by 5. Okay, thank you. Next question will go. So look, my dear students, even here one more previous year JEE mains question will be there. Energy of ground state of hydrogen atom is minus 13.6 electron volts. Ground state of hydrogen atom. Then the energy of second excited state of helium plus ion in the electron volts is, that is the question actually. So energy of nth orbit find out cheyadaniki formula. Energy of nth orbit of hydrogen atom is equals to minus 13.6 into then z square divided by n square. This is the formula. Z square divided by n square. N square. This is the formula. So this is for energy of nth orbit. Clear? Then, sir, here for hydrogen atom Z equals to 1. Then ground state. Remember, when the ground state is mentioned, then n value it is equals to 1. N value equals to 1. In case first excited state is mentioned, then n value it is equals to 2. So in case second excited state is mentioned, then n value it is equals to 3. That you have to remember. So here for the hydrogen atom is a ground state only. Na? So ground state n value 1, then even Z value, atomic number value 1. So that's what the hydrogen atom of energy of ground state is equals to minus 13.6 only. Clear? So according to the electron volts, that is. Next, they're asking energy of second excited state of helium. So at that time, say energy of helium plus ion in case if you take, then minus 13 point, same formula you have to take, E formula in each. So minus 13.6 into Z value. Z atomic number for the helium is 2, so 2 square divided by second excited state, n value how much you have to take? 3. So 3 square you have to take. That is 9. So minus 13.6 into 4 divided by 9. Then you can get it is minus 6.04 electron volts. This is the formula if you're solving that. Okay. So we'll see the next question. Note it, all of you. Note it. Yes, look, my dear students, this is one of the previous year question. So based on the wave function they are mentioned. So actually, if you observe this question, JEE mains 2023 January shift lo vachina question idi. The wave function psi of 2s is given. So 2s of, so n value 2s value, l value 0, that is. Then psi 2s it is equals to 1 by 2 into root 2 pi. Then 1 by a naught power 1 by 2. Then 2 minus r by a naught into, then e power minus r divided by 2 a naught. This equation is given in this. Then at r equals to r naught, radial node is formed. Remember, when radial node is formed, then psi 2s value should be 0. Okay, clear? Thus r naught in terms of a naught. So what? Eppudu radial node form ayinappudu r naught value in terms of a naught lo enta ani adigadu question. So observe this. Radial node form avute, sir, psi value అంటే ఈ టోటల్ వాల్యూ 0 అవ్వాలి. ఈ టోటల్ వాల్యూ 0 అవ్వాలంటే ఇక్కడ 4 టర్మ్స్ ఉన్నాయి. సో టర్మ్ నెంబర్ 1 దట్ ఈస్ 1 divided by 2 into root 2 pi. Then term number 2 it is 1 by a naught whole power 1 by 2. Sir, a naught ante ikkada Bohr's orbit. So Bohr's orbit, what is that? Length of Bohr's orbit. radius of both orbit. Then here 2 minus r divided by a naught. Then e power, then minus r divided by 2 a naught. Remember, 4 terms ఉన్నాయి. ఈ 4 టర్మ్స్లో ఏదైనా ఒక టర్మ్ జీరో అయితే టోటల్ వాల్యూ జీరో అవుతుంది. సార్ ఫస్ట్ టర్మ్ జీరో అవుతుందా? సో ఫస్ట్ టర్మ్ కాన్స్టెంట్ వాల్యూ, ఇది జీరో అవ్వదు. కాన్స్టెంట్ వాల్యూ 1 divided by 2 into square root of 2 pi. This value nearly 0.19 something will come. So ఇది జీరో అవ్వదు ఈ వాల్యూ. సో దెన్ ఇక్కడికి వచ్చేసరికి సార్ 1 divided by a naught, సో హోల్ పవర్ 1/2. సార్ ఏ నాట్ వాల్యూ ఎంత? 0.519. So that is the radius of first orbit. So in the angstrom, so the 1 divided by 0.529, then 1/2. So e value kuda not equals to 0. So even this is constant value, it won't 0. So constant value 0 avadu, idi 0 avadu. Then next term ఇది చూడండి ఒకసారి. సో వాట్ ఈస్ దేర్? ఈ పవర్ మైనస్ ఆర్ డివైడెడ్ బై 2a naught ఈ వాల్యూ ఉంది. సో దిస్ ఈజ్ ఎక్స్పోనెన్షియల్ టర్మ్, we call exponential term, never zero. So already we know that it is one of the property of exponential term. So never zero it is. So when it is never zero, then remaining what will be there? Only this term will be there. So what is this term? 2 minus r by a naught. This value, it becomes 0. Yes, we are taking it as a 0. So once if it is 0, 2, it is equals to r divided by a naught. Then r equals to, you can get, so 2a naught. Then r when it is r naught. So r naught equals to 2a naught. R naught equals to 2a naught. So this is the formula, r naught equals to 2a naught. This is the answer. Okay, thank you. So note it. So next question will go. Yes, look at here, one more previous JEE question will be there. Based on the Heisenberg uncertainty principle, the uncertainty in the velocity of electron to be found within the atomic nucleus of diameter 10 to the power of minus 15 meters is dash in 10 to the power of dash into 10 to the power of 9 meter per second. So what we have to find out? The velocity, uncertainty in the velocity of electron we have to find out. Sir, according to or based on the Heisenberg uncertainty principle, what will be there? Then delta V into delta X, it is equals to h by 4 pi m. Sir, we know that delta V nothing but uncertainty in the velocity, delta X nothing but uncertainty in the position, then h Planck's constant 4 pi m. M is the mass of electron, 9.1 into 10 to the power of minus 31 kg. This is mass of electron, right? Then delta V value you have to find out. So delta V, in case if you want to find out, delta V, it is equals to h divided by then 4 pi m into delta x. So remember, so all the values substituted. Then h value 6.63 into 10 to the power of minus 34, right? Then 4, then pi value 3.14, right? Pi value, constant value 3.14. M value, mass of electron, what will be there? So that is 9.1 into 10 to the power of minus 31, sir, into then delta x value. So delta x, that is the position, 10 to the power of minus 15, 10 to the power of minus 15. Then you can get the answer. It is a 57 point, when it is solving, 57.99 into 10 to the power of 9 meter per second. So this is the answer for this. Just note it, all of you. Yes, look, my dear students, here 2 more previous year questions are there from the JEE mains itself. So first question is based on the radial nodes. So look at for the 8th question, the question number 8, radial nodes. The nodes actually, two types of nodes are there, angular nodes and as well as radial nodes. Sir, angular nodes, the L value, L is the formula. So L what will be there, that only, the L value how much is there, that only angular node. Radial node, that is equals to N minus L minus 1. Sir, N minus L minus 1. Sir, we know, remember that L values, L it is equals to, L it is equals to 0, then 1, then 2, then 3 when it is present. L value 0 is there, then that is belongs to S orbital. L value 1 is there, that is P orbital. L value 2 is there, that is D orbital. L value 3 is there, that is F orbital, right? So these are the L values for it. Then, sir, here they are asking radial nodes in this question. Radial nodes. So radial nodes for 3p orbital. 3p. So 3 in the 3p orbital, n value how much? N value is 3. 3 minus L value how much? P orbital, L value is 1. So minus 1. Then minus 1. Then you can get 1. You can get 1. So 3 minus 2, that is you can get 1. So A value, A answer is A, that is 1. Clear all of you? So that is the formula to find out the radial nodes. So now next question, sir, based on the quantum numbers they are given, look at, based on the quantum numbers. The maximum number of orbitals which can be notified with the n equals to 4, ml equals to 0. Remember when n equals to 1, only one orbital is present in it. That is, so one s orbital is present. The first cell, n equals to 1 nothing but first cell. First cell n orbital untai, okate orbital untundi. Then n equals to 2, then how many orbitals are there? 2 orbitals are there, that is 2s comma 2p. Then n equals to 3, then 3s comma 3p comma 3d. Clear? Sir, here they are given n equals to 4. Manaku kavalsindi n equals to 4 matrame. N equals to 4 ఉన్నప్పుడు sir ఎన్ని ఆర్బిటాల్స్ ఉంటాయి? Sir 4s1, then 4p, then 4d, 4d, then 4f. 4 ఆర్బిటాల్స్ ఉన్నాయి. Sir, ఇందులో m value 0 ఉన్న ఆర్బిటల్, sir 1 is there. Then ఇందులో actually only one orbital, that is m value, when L value equals to 0, m value almost 0. Then p orbitals, so look at px, py, pz. Sir, px, then py, then middle orbital we can take it as pz, right? So for the pz orbital, always m equals to 0. So here one orbital is there. Then even here also d. Then if you take 5 orbitals, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sir, even in this, sir, one of the orbital, that is dz square orbital, that is m value 0. You have to remember. So here one orbital is there. Then in the 4f also, one of the orbital, that is m value 0 orbital is there. So 1, 1, 1, 1, totally 4. So 4 orbitals are present in it. 4 orbitals, elanti orbitals ante n value 4 undi m value 0 ఉన్న orbitals ఎన్ని? m value 0 ఉన్న orbitals ఎన్ని? 4. సో 4p లో ఒకటి, 4d లో ఒకటి, 4f లో ఒకటి, then 4s లో ఒకటి. Clear? Yes, note it, both questions. So look at, my dear students, even here one more previous year question is there, JEE mains question only. The correct decreasing order of energy for the orbitals having following set of quantum numbers. So quantum numbers are given, energy of orbitals they are asking. So look at, energy of orbitals are depends on n plus L value. Energy of orbitals depends on n plus L values. So these are not depends upon the m values actually. M values may they depend above. Sir, n plus L values. Sir, already I told that L it is equals to 0, S orbital, 1 P orbital, 2 D orbital, 3 F orbital, like this. Then n values are quantum number values. The first option, if you check it, sir, n plus L value, A ki చూసుకుంటే n plus L value 3 plus 0, 3. Then B if you take, then 4 plus 0, 4. Then C if you take, then 3 plus 1, 4. Then D if you take, sir, D 3 plus 2, 5. Remember, higher n plus L value, higher n plus L value, higher n plus L value, higher energy. Higher energy. So energy ni base cheskoni, n plus L value ni base cheskoni, D is major, yes, D is the more energy. Once the same n plus L values are there, at that time you have to take, sir, A options B and C. రెండు ఆప్షన్స్లో n plus L వాల్యూ సేమ్గా ఉన్నాయి. 3 plus 1 4, then 4 plus 0 4. At that time n value only have to consider. n value దేనికి ఎక్కువగా ఉంటే అదే higher energy. So B option is correct. So B option is correct. Then after C option have to take. Then after later, sir, which one you have to take? A option you have to take. Clear all of you? So this is the answer, D, B, C, A. So D, B, C, A. This is answer. Clear? Just note it all of you. Question and answer both note it. It is useful for you. Look at here, one of the question is there. This question 2025 లో EAPCET లో వచ్చిన question. So in Telangana state lo, AP state lo వచ్చిన question it is. Sir, observe it carefully. The radius of stationary state of n equals to 2 of hydrogen atom is x picometers. Then the radius of stationary state of n equals to 3 of helium atom is what? They're asking question like this. So observe it carefully. Sir, actually, in case if you take the radius of stationary state, that is n equals to 2 of hydrogen atom. Sir, radius of nth orbit is equals to a naught into n square divided by z. Sir, in the stationary state they are mentioned, it is what? 2. So in the place of n value, you have to take 2. So then z value hydrogen atom is 1. So if you take that, the radius of nth orbit is equals to, sir, a naught into, in the place of n, 2 square nothing but 4. So 4 divided by 1. So then our radius of nth orbit, it is equals to 4a naught. So radius they are given x picometers, then x it is equals to 4a naught. Remember, 4a naught. Clear? Next you have to go for radius of then stationary state n equals to 3 of helium atom. Then the same formula you have to take, that is a naught into then n square divided by z. So here n value 3 have to take, z value helium 2 you have to take. So in the place of this r, you have to take r equals to, sir, a naught into, then the place of n square 3 square nothing but 9 divided by z 2 we have to take, right? So from this we can find out the a naught value. So a naught is equals to x divided by 4. x divided by 4. So in the place of a naught we can substitute x divided by 4. So r equals to, in the place of a naught, x divided by 4 into 9, then divided by what? 2. So then r equals to 9x divided by 8. So 9x divided by 8, where will be there? This is the answer. 9x divided by 8. Clear all of you? Understand? Yes, just note it all of you. Then we will go for the all EAPCET questions. Yes, look at my dear students. Here one of the previous year EAPCET question will be there. When electromagnetic radiation of wavelength 310 nanometers falls on the surface of the metal, having work function 3.55 electron volts, The velocity of photoelectrons emitted is x into 10 to the power of 5 meter per second. The value of x is, so x value ni find out cheyali. So look at actually the photoelectric effect question. The photoelectric effect law, so energy of light is equals to work function plus kinetic energy. This is the formula, right? This is the formula. Sir, before going to this formula, first energy of light you have to find out. Sir, energy of light find out cheyadaniki, sir, energy electron volts lo undi, then wavelength nanometers లో ఉన్నప్పుడు then 1240 divided by wavelength in the nanometers. ఈ ఫార్ములా యూజ్ చేస్తే సింపుల్ షార్ట్ కట్ అవుతుంది. సో ఎనర్జీ ఫైండ్ అవుట్ చేయడానికి సర్ 1240 divided by then 310, what will be there? Wavelength 310 will be there, 310 nanometers. Then you can get energy is 4. So 4 electron volts. Now from this formula itself, sir, work function they are given 3.55. Sir, if you calculate the kinetic energy equals to energy minus then work function. Energy 4 is there, work function 3.55 electron volts is there, then 0.45 electron volts you can get. Sir, in case the kinetic energy if you want to take in the joules, sir, 1 electron volts equals to 1.602 into, remember, 1 electron volts equals to 1.602 into 10 to the power of minus 19 joules. This formula I have to take. So here the kinetic energy in the joules 0.45 into then 1.602 into 10 to the power of minus 19 have to take. This is the kinetic energy. Sir, this you can get in the joules laws. Sir, later, then what you have to find out? The work function is given. The velocity of electron from this you have to get. So kinetic energy nothing but, sir, half into mv square. It is equals to, now what you got, 0.45 into 1.602 into 10 to the power of minus 19. You got it, is right? Then velocity is required, right? Velocity is required. So velocity want to required means velocity equals to square root of velocity is equals to square root of so look at the kinetic energy is equals to half into mv square. Yes, 2 into kinetic energy divided by mass of electron. The mass of electron is given 9.1 into 10 to the power of minus 31, right? So all the values substitute in it. Sir, square root of 2 into kinetic energy, how much you got? It is, so that is 0.45 into 1.602 into 10 to the power of minus 19, then divided by mass of electron 9.1 into 10 to the power of minus 31, then velocity can get square root of 1.6 into 10 to the power of 11, then that is equals to square root of 16 into 10 to the power of 10, that is equals to 4 into 10 to the power of 5 meter per second you can get. So the x value, so 4 into 10 to the power of, sorry, x value how much you can get? 4. So 4 is the answer. Clear? Understand all of you? Just note it. Yes, look at the next question all of you. The radius of first Bohr orbit of hydrogen atom is same as that of orbit n of hydrogen like species X. Then n and x values respectively are. They are given like this. So radius of first Bohr orbit of hydrogen atom is same as that of the orbit of n hydrogen like species. First radius of first orbit of hydrogen atom is what? 0.529 into n square divided by z. N square divided by z. This is the formula for radius of nth orbit. Then hydrogen like species, the first orbit annappudu, the n value we can get 1, then z value we can get 1, then radius of first orbit of hydrogen atom 0.529 you can get, right? Clear? Now hydrogen like species annappudu, the only one condition you have to remember, n square z value both should be equal. N square it is equals to z. ఈ కండిషన్ అప్లై అవ్వాలి. సో ఈ కండిషన్ అప్లై అవ్వాలి అంటే దేనికి ఫార్ములా అప్లై అవుతుందో చూసుకోవాలి. సో లుక్ ఎట్ హియర్ n square in case 2 square, if you take z value, that is 4, atomic number 4 will be there, then you can get it is equal, right? Then sir, where it is z value 4? The beryllium plus 3, z value is 4. So beryllium ke z value anta? Yes, 4. Then n value how much is given? 2. So option is this. Clear? Understand all of you? So once both will be there, radius of then second orbit of beryllium atom, beryllium ion if they were given, then 0.529 into n square value 2 square, then z value 4, 4 2 square cancel, then r equals to 0.529 only can get. So what they told that the same as that of yes 0.529, 0.529, same both, right? Yes, note it all of you. Next question we'll discuss. Yes, look at the next question. Radius of third orbit of hydrogen atom is r picometers. R picometers. The radius of second orbit of helium ion is in the picometers is there. Asking question like this. So actually radius of nth orbit is equals to a naught into n square divided by z. This is the formula. So the hydrogen atom తీసుకుంటే hydrogen atom ki third orbit ఇచ్చాడు అంటే n value is equals to 3, then z value you can get 1, then radius of nth orbit is equals to a naught, so into in the place of this 3 square nothing but 9, then so they are mentioned this is the radius, but this is r picometers. In the place of radius you have to take capital R, it is equals to so 9 a naught, right? So in case if you want to get a naught, say a naught equals to then r divided by 9. Clear? So now next what will be there? So second orbit of helium atom. So second orbit of helium atom, what you have to take, radius of nth orbit is equals to a naught into n square, second orbit 4 divided by z, helium atom 2, right? So 2 1s are 2 2s are, yes. So radius of nth orbit of our second orbit of helium atom, helium plus ion, it is equals to a naught into 2. So a naught value how much is there? R divided by 9. So 2 into r divided by 9. This is the formula. This is the answer for this. So 2 divided by 9 into r. This is the answer for this. Clear? Understand all of you? Yes. Note it. So look at here, the statement type of question is there. The two statements are given. Statement number 1, in hydrogen atom, the energy of 2s and 2p orbitals is same. The statement number 2, in the helium atom, the energy of 2s and 2p orbitals is same. So the statement 1 and 2 both are correct, 1 and 2 both are wrong, then 1 is correct, both second one is wrong, then first one is correct, not correct, second one is correct. Like this is given. So first statement 1 చూస్తే in hydrogen atom energy of 2s and 2p orbitals is same అని ఇచ్చాడు. Then second statement లో helium atom 2s and 2p orbitals is same అన్నాడు. atom చేంజ్ చేశాడు బట్ సేమ్ అన్నాడు both. సరే ఇక్కడ ఒక స్టేట్మెంట్ మీరు అబ్జర్వ్ చేయాల్సింది, the energy of orbitals it is depends upon principal quantum number and as well as azimuthal quantum number. N and L, but except in the hydrogen atom, energy of orbitals depends upon only principal quantum number, remember. So remember, it's very, very important. In hydrogen atom, energy of orbitals depends on only principal quantum number. Principal quantum number, that is small m. So అందుకోసం మన ఎనర్జీ ఆఫ్ హైడ్రోజన్ atom కి సార్ 1s ఆర్బిటాల్, then after 2s equals to 2p, then after 3s equals to 3p equals to 3d, then after 4s equals to 4p equals to 4d equals to 4f. So like this we can write. But other atoms not like this. So now whatever the remaining atoms are there, it is depends upon both n value and l value. So ikkada n value, l value తీసుకుంటే సరే n value is 2, then l value 0, then n plus l value you can get it is 2 for the 2s orbital. For this 2p orbital, 2 plus 1 equals to 3. So 2, 3. So not same energy. 2, 3 not same energy. So statement 2 is wrong. Statement 1 is correct. So statement 1 is correct, but statement 2 is wrong. So C option is correct answer. So nowadays maximum they're asking statement type of questions. Please be focused on statement type of questions if you learn. So look at, my dear students, here one of the previous year question is there. The energy associated with electron in the first orbit of hydrogen atom is minus 2.18 into 10 to the power of minus 18 joules. Joules లో ఇచ్చాడు ఎనర్జీ. సో ఇంతకుముందు మనం ఎలక్ట్రాన్ వోల్ట్స్లో చూసాం, minus 13.6 into electron 6 electron volts. The frequency of light required to excite the electron to fifth orbit is. సో యాక్చువల్గా ఎనర్జీ ఆఫ్ ఎలక్ట్రాన్, సో చూడండి, ఇది n ఈక్వల్స్ టు 1 అనుకోండి, ఇది 2 అనుకోండి, 3 అనుకోండి, 4 అనుకోండి, n ఈక్వల్స్ టు 5 అనుకోండి. ఎలక్ట్రాన్ ఇక్కడ నుంచి ఇక్కడికి జంప్ అవ్వడానికి ఎనర్జీ ఆఫ్ లైట్ ఫ్రీక్వెన్సీ హౌ మచ్? లైట్ ఫ్రీక్వెన్సీ, లైట్ రిక్వైర్డ్, ద ఫ్రీక్వెన్సీ ఆఫ్ లైట్ రిక్వైర్డ్, దర్ ఆస్కింగ్ క్వశ్చన్. సో అది తెలియాలి అంటే ఫస్ట్ ఎనర్జీ ఆఫ్ ఫస్ట్ ఆర్బిట్. సో ఎనర్జీ ఆఫ్ ఫస్ట్ ఆర్బిట్ ఇస్ ఈక్వల్స్ టు minus 2.18 into 10 to the power of minus 18 into then z square by n square. This is the formula, z square by n square. సో ఫస్ట్ మనకి హైడ్రోజన్ ఆటమ్ ఇచ్చాడు కాబట్టి అది కూడా ఫస్ట్ ఆర్బిట్ అన్నాడు కాబట్టి, సో దట్ ఈస్ ఫస్ట్ ఆర్బిట్ minus 2.18 into 10 to the power of minus 18 joules అవుతుంది, because z value 1, n value 1. Clear? Yes. Then in case energy of fifth orbit తీసుకుంటే minus 2.18 into 10 to the power of minus 18 in the place of z square. సరే ఇది ఏ ఆర్బిట్? ఫస్ట్ ఆర్బిటే కాబట్టి z square 1 square need not to take. Then n square, that is 5 square. Then it is equals to minus 2.18 into 10 to the power of minus 18 divided by, so 5 square you can get 25. Then this value finally you can get minus 8.72 into 10 to the power of minus 20 joules when it is solved. So now the change in the energy gap, delta E, it is equals to E5 minus E1. Look at, so E5 value how much is there? Minus 8.72 into 10 to the power of minus 20 minus of minus, then E1 value how much is there? The 2.18 into 10 to the power of minus 18 joules. Then this we can get that is 2.07 into 10 to the power of 2.07 into 10 to the power of minus 18 joules you can get. 2.09 into 10 to the power of 18 joules you can get. The change in the energy. Now delta E, it is equals to hc by lambda. So, or otherwise h nu frequency is required, not lambda, wavelength kaadu, h nu, the frequency is required. So frequency kavalante nu it is equals to delta E divided by h. Delta E value 2.09 into 10 to the power of minus 18, then divided by h value 6.63 into 10 to the power of minus 34, right? Then finally you can get the answer. 3.17 into 10 to the power of 5. So 10 to the power of 15. That is in what frequency? So frequency. Cycle per second. Okay. Right. Hertz or cycle per second, the frequency. I'll look at one more question. The sum of total number of neutrons present in protium, deuterium, tritium. Protium, deuterium, tritium, these are three isotopes of hydrogen atom, we know. So protium is 1H1. Then deuterium is 1H2. Then tritium is 1, 3. So number of neutrons find out cheyalante, then mass number minus Z. Then 1 minus 1. Then you can get it is 0. 1 minus 1 you can get 0. Then here mass number 2 minus atomic number 1. Then you can get 1. Then here the mass number 3 minus 1 you can get 2. So total number of neutrons in it are 3. 0 plus 1 plus 2 are 3. So answer for this is 3. So this is 2021 previous year EAPCET question, EAPCET question, Telangana state EAPCET question. So next question, look at my dear students, here one of the EAPCET question will be there. That is, then which of the following are isoelectronic species? Isoelectronic species ante same number of electron containing species. Same number of electrons containing species. Same number of electrons containing species. So first one, what is given? O minus 2 is given. So O minus 2 లో number of electrons ఎన్ని ఉన్నాయి అని ఎలా ఫైండ్ అవుట్ చేయాలంటే, ఫస్ట్ అటామిక్ నెంబర్ ఆఫ్ ఆక్సిజన్ హౌ మచ్? అటామిక్ నెంబర్ ఆఫ్ ఆక్సిజన్ is 8. So 8, the minus 2 ఉందంటే charge of 2 electrons. So 2 electrons plus 2 electrons తీసుకుంటే then total number of electrons are 10. Then అలాగే then F minus 1. F minus 1. So atomic number for this is 9. Then 9 plus 1 it is equals to how many electrons? 10 electrons. Then atle sodium తీసుకుంటే, then sodium if you take Na plus is given. Look at atomic number, we know that 11. The plus is there, nothing but one of the electron is removed from it, right? So 11 minus 1 it is equals to 10 electrons. The same like that even magnesium also, Mg plus 2. Then Z atomic number is 12. Then 12 minus 2 plus 2 అంటే 2 electrons remove చేశారు. Then 10 electrons. So all are isoelectronic species only. So 1, 2, 3, 4 is the correct answer. Okay, yes, note it. Next question we'll discuss. Look at my dear students, here previous year question, this is also based on the scientists they're asking. Generally in the atomic spectrum, structure of atom, in the structure of atom. So here first one, Chadwick, Rutherford, Moseley, J.J. Thomson. Sir, in this generally based on the fundamental particles, electrons, then protons, then neutrons, if you take. Right here, James Chadwick is the discovery of neutrons. So discovery of neutrons, James Chadwick neutrons will find out. Then Rutherford is there, Mosley is there, J.J. Thomson. J.J. Thomson ante everyone they knows that electrons. సరే ఎలక్ట్రాన్స్ అని ఫైండ్ అవుట్ చేసింది జేజే థామ్సన్. సో బేస్డ్ ఆన్ దిస్ ఇస్ ద క్యాథోడ్ రేస్. సో క్యాథోడ్ రేస్ని బేస్ చేసుకొని చేశాడు కాబట్టి సో దెన్ ద క్యాథోడ్ రేస్ ఈజ్ ఆన్సర్ ఫర్ దిస్. నెక్స్ట్ రూథర్ఫోర్డ్ అండ్ మోస్లే. సార్ మోస్లే ఇన్ కేస్ ఇఫ్ యూ టేక్ మోస్లే దిస్ ఈస్ బేస్డ్ ఆన్ ది అటామిక్ నెంబర్. అస్ మోస్లే ఫైండ్ అవుట్ చేసింది సో ఎక్స్రేస్ when it is bombarded with X-rays are bombarded with heavy metals, heavy target metals, then the frequency of X-rays is directly proportional to atomic number అని ఒక ఫార్ములా ఫైండ్ అవుట్ చేశాడు మోస్ట్లీ. సో the frequency of X-rays, that is X-rays, so this is belongs to X-ray spectra. Next Rutherford atomic model or nuclear model of atom equal. Sir, Rutherford, what he told, the nucleus is present, the electrons are revolving around the nucleus in a circular paths they are mentioned. So how that is sun planets are revolving around the sun, so same like that. So that's what we are calling it as a nuclear atomic model. So planets, how they are revolving around the sun, same like that electrons also revolving around the nucleus. So these are the important questions. These are the previous year questions from the structure of atom chapter. So remember, from the today onwards, every day daily 7 to 8 o'clock live classes will be there. So every day one chapter I will discuss previous year EAPCET question papers answers, then JEE mains previous year questions, that all will discuss. Then in case anybody they are not subscribe my channel, then subscribe it, then like it, then share it, then tell them to many of the students those are not able to attend the EAPCET coaching. So those are poor students are there. Better to listen these classes, then you can get somewhat knowledge to write EAPCET questions, EAPCET. Thank you.